Great. Well, thanks for the opportunity to be here. I'm Andy Robinson. I serve as an extension potato agronomist at NDSU as well as the University of North Dakota, or NDSU and the University of Minnesota, sorry. Today I'm going to be talking about herbicide injury in potatoes. I do a lot of different things. Herbicides are just one of them. It's just one of these things that I kind of got into when I first started my position. We had a number of issues pop up, and since then, just kind of been dealing with those and educating people about herbicides and some of the disadvantages they can have in potatoes too. So one of the things that often comes up is the question, are we seeing more of these herbicide issues because is it noticed more often, or is it because weeds are getting more difficult to control in neighboring fields and maybe more products are being used or at different rates, or maybe a combination of the two? But either way, the reality is there are some problems from time to time. It's not wide scale, but when a grower does have a problem, it's a big deal. And as a result of herbicide issues, we could have poor emergence, we can have disrupted plant growth, and ultimately that's going to affect your yield as well as your tuber quality. So question often becomes, why is this a problem? And like I said, reason is there's a number of reasons. It reduces your stand. You can have slower canopy closure, damaged leaves, tubers, reduced yield and quality. So all those things are reasons why this is a problem in our potato production systems. So how does this happen? There's basically a few different ways that this can occur. One is carryover in soils, which is, of course, from previous applications of herbicides. There's certain techniques you can use when it's in the soil. It's trying to look for patterns, and so usually a soil-borne herbicide or residue is going to be throughout the whole entire field. When it's there, you can usually do testing of some sorts to figure out exactly what it is, and then you can get that positive confirmation. Oftentimes, we send samples to a laboratory once we narrow down what the potential symptoms look like, so that we have a pretty good idea of what it is. So, sorry, my slides are being jumpy. This is kind of an interesting diagram here. When you have herbicides applied to a field, they have to do something, right? And this diagram is kind of cool because it shows all the different things that can happen, right? Ideally, you want it hitting the weeds that you're trying to control, but it can drift, it can volatilize, it can run off, it can be broken down by sunlight, etc. So there's a lot of different things that can happen to a herbicide when it's applied. So when we talk about exposure to herbicides, these are some of the major ways that we typically have soil or plants having herbicide contact them, or potatoes. So you can have soil carryover, certainly, like we talked about. Seed contamination is an issue from the seed side when that plant the previous year was exposed to a herbicide that's stored in the tuber. And a lot of times these things can happen through drift and tank contamination. So it's important to follow the label when it comes to soil carryover. Some labels are really specific, such as the Amazamox label. It could be 9 or 18 months, depending on what the situation is. When you're renting land, it's important to know what the previous probably 2 cropping systems herbicides were applied, because some can last for up to 2, maybe even 3 years on potatoes. And then keep in mind, your tanks need to be cleaned properly because they can also cause injury. So when we have soil carryover, typically what's going to happen, those roots are going to be exploiting the soil. They're going to be pulling up water, nutrients, etc., into that plant, but also those herbicides, if they're in those soil system, the plant can pull those up, and they can eventually be stored in the tubers or the leaves of the plant. So here's kind of a fun diagram, kind of shows you way different herbicides may contact the plant. And so you've got your contact, like your Reglan, it's only going to affect what it touches. Your root contact, like your metolachlor or dimethenamine type products. You have those xylem mobiles like metribuzin, Syncor, and then you have some that are phloem mobile like Roundup, and then you have those that are xylem and phloem mobile. I got Matrix here, but I know in Canada you guys call it Prism. It's rimsulfuron, so it's an active ingredient. So what do you look for when you have soil carryover? Like I said, you're going to be looking for wide areas in the field that kind of show the symptoms. Sometimes it's the pass of a sprayer or a tank, that might have been contaminated. Sometimes you'll have to look for different changes in the soil, high or low spots that can show differences. But as a result, often you'll see slow emergence. You might see roots that are affected, tubers that might be affected, and even kind of the early setting of tubers, because when plants are stressed, their whole purpose is to reproduce. And so they're going to try to put tubers on. So here's an example from a field where we had some soil carryover of a herbicide called imazethapyr. Pretty bad on the potato plants. You can see it close up here. You get typical symptoms of this. These leaf tips tend to be skinnier with more of a kind of a skinny tip at the end of them. If you look at the roots, classic symptoms for this type of chemistry, we often refer to as the IMIs. You'll see this bottle brushing of roots. And then, of course, the tubers are pretty ugly too. So this is a good result of a soil carryover. Here's another case where a sprayer boom was cleaned out in the field. And you can see here the sprayer boom probably put way too much herbicide in this location. And as a result, the plants were stunted and didn't grow well. This is a case here where there was wheat in this field, I believe the previous year. It's the compound clopyralid, and it's fairly water mobile, so it went to a low spot in the field and caused a fair bit of damage from that. So there's a lot of things that can cause them. There's a lot of things also can cause soil carryover problems that aren't herbicides. So this is the fun picture. On the left, you'll see nice green growing plants. And actually that half on the left was fumigated and the half on the right was not fumigated. And this was actually a nematode problem, a root lesion nematode issue that we dealt with. And these are some of the pictures of what it looked like. But as we tried to figure this out, we tested for all kinds of things, including herbicides, and there was no herbicides involved. So anyways, you just got to be careful what you're looking at. Not every time that you have an injury or damage, it can be a herbicide. There's a lot of other things that can happen, including diseases, nematodes, physiological problems. So anyways, but jumping on the foliar exposure, a lot of things can cause exposure to the leaves. Like I said, the most common ways are probably through tank contamination and drift. So it's really important to clean out your tank. It's really important to not drift. Talk to your neighbors, let them know that you have potatoes nearby. And also those that are spraying, make sure you train them. Those are all really important keys, I think. If you're a seed grower, we highly encourage seed growers to have their own sprayer just for their potatoes and use a different sprayer for the rest of their crops. It's a really easy way to potentially prevent issues. It's a good insurance package, I would say. So when you have products that hit the plant leaves during the growing season, what are they going to do? And probably the most common ones we deal with in potatoes are going to be that I deal with at least are your group 2s, 4s, and 9s. 9 is going to be your glyphosate. And these are going to be mobile within the plant. They're typically going to go to the growing points, the younger leaves, and then down into the tubers or roots. And therefore, they often can be stored in the tubers as a result of this exposure. And so when we're looking for this injury, we're looking for it in the younger leaves. And if we're testing in labs, we're testing the leaves, and we're often testing the tubers as well. Don't just do one because you might miss it because it depends on that source strength relationship. And so sometimes, like late in the growing season, those tubers will be pulling most everything down into them as they're trying to finish the season, and you may not see anything in the leaves. So some of the symptoms you're going to see with our growth regulators, our group 2s, pretty common. We often refer to this as epinasty. It's kind of the twisting, cupping up of leaves. The glyphosate, your group 9s, is typically those youngest leaves. You're going to see a little bit of yellowing in the leaflet margins. It can crack the tubers or distort them. And the ALS inhibitors are going to also be similar to the glyphosate in a lot of ways. They're going to cause yellowing in the leaves. I mean, both glyphosate and ALS, they're inhibiting amino acids from forming, and so they kind of have a similar result. So if you do have a drift, we're always looking for field patterns. Okay, it's typically from an edge. You might see an ebb and flow from the edge, as these diagrams show. The arrow indicates the direction of the wind. But it's going to look like that. Here's an example of a field that was exposed to glyphosate, and you can see here how yellow these leaves were. This is a pretty atypical result, but very, very, very noticeable. And this can happen. There's a soybean field right next to this field. Sprayer that was spraying, they sprayed it twice with glyphosate, and both times the wind was blowing in direction of the potato field. Here's just another angle of that. It looks like it may only go in a few meters, but actually you could go probably about 75 meters and into that field, and they could see symptoms still. Just they're very subtle, but they're able to be seen. And this is just a quick close up here. Again, here I'll point out right here, these leaflet margins, you'll see a little bit of yellowing in these leaflet margins. That's what glyphosate will do for you when you have it in the field. So other things to think about, again, don't come running every time you see yellow leaves calling it glyphosate, because there's a lot of other things that can happen in potatoes. So drought stress might make it look like a growth regulator. a group 2, because sometimes the leaves might cup and twist from that. Fertility stresses, iron deficiency can cause yellowing in the upper leaves. PBY, potentially phosphoric acid. So there's a lot of different things that can cause injury in the leaves, and it's not always a herbicide. So that's the important thing to keep in mind. So this is phosphoric acid. Oftentimes in the Midwest, we'll see a little bit of burn from this. But as you can see here, you see some yellowing, which may resemble a herbicide, but it's not. And then on the right, you see a little bit of spot burning from it. Also, the spot burning can happen also from contact herbicides as well. PBY, again, is another thing I mentioned. It can cause the chlorotic color in the leaves. And then we get to our tank and boom contamination issues that we sometimes see. Here's a great example of a boom that was not cleaned out. You can see right where the tractor tires go and where the boom would be. And sometimes just a little bit of herbicide left in that tank can cause a lot of problems. And I've done the math calculation, just a couple tablespoons of glyphosate can cause injury in a field. So here's an example of trying to control some leafy spurge the county was trying to do, and it went into a potato field. And as you can see, some pretty significant damage. And so when we're dealing with these group 2s, it can cause fairly significant injury to that growing point. And you'll notice that here where that growing point's at, right in this area, that's significantly damaged. You're not getting good growth, new growth from those leaves. You see the curling and twisting and bending. Here is picloram is the product that was in this case. Again, you can see some of these stolons are a bit crinkled and the leaves are bumpy. Tubers, again, don't look very good. They're distorted in shape and not growing accordingly. You see, such as the Mazabox, it can cause cracking in tubers like you can see in these photos. Just some trials that were not really trials, more demos that we did for field days for growers. 2,4-D, very common, typical epinacea symptoms. Sometimes the eyes can get a little bit deeper on the tubers when that happens. And then, of course, there's all the growth cracks and cracking and things like that that can happen on tubers. A lot of things can cause cracking. Herbicides definitely play a role, but any kind of stress pretty much in the plant, environmental, nutritional, disease, even genetic stresses can cause tuber cracking. So it's really difficult sometimes to tell if the tuber's cracked, what's causing it. And the deeper the crack typically means the larger the crack. So when it happens in the early growth phase of the tuber and you disrupt that cell growth, as it grows bigger, that crack gets bigger. So here's just a quick little kind of little poster thing we put together. There's a quick link on the bottom right if you want to grab it. But the point is I'm putting it up here. What you can see here, when we're showing herbicide injury from a lot of different types of herbicides, what you'll see is most of the time you're going to cause some kind of stress to that plant, which is going to affect that tuber. And so you're going to get tuber cracking, malformations of the tuber, and it just disrupts the growth. So, and that's typical, pretty typical of herbicides. The only time you may not see it so much is if the rate is extremely low, or if it happens very late in the season when the bulking and the growth of that plant is almost finished. There's just not enough time for that tuber to grow and to continue to show those symptoms. So cracking is a symptom, but it's a symptom of multiple things, and that's where you have to be careful. So sometimes we get misapplication. This is just a little soybean field I drove by one day and noticed they put the wrong product around the whole field. We've seen fields too like this where the wrong plane load gets loaded and sprayed on a potato field. So, stuff like this happens. Everything pretty much happens, and I'm never surprised when something new happens anymore. But when you do have a seed contamination, it's important to track that seed, see if there's other lots planted around that may have the same symptoms. Not always the case, because if it's just the edge of the field, the seed gets affected. It may only be 1 or 2 loads of the seed that has a problem. If you do see any kind of problems, it's important to get it tested soon, because the longer you wait, the more the symptoms go away and you may miss it. If you are picking up seed to plant and you question it, you can always get the seed tested. You could do a quick grow out, do something just to make sure it's good, because you have to have good seed to have a good crop ultimately. So when you have glyphosate, this is probably the one I deal with the most, I've seen the most of, but glyphosate injury to the plant, typically going to cause smaller tubers. These are pretty severely affected here. Ones we did in our research, we intentionally sprayed, but folds, cracks, sometimes elephant hide on the skin can happen. We do get the no symptoms when it is late in the season and we're not able to have any more growth pretty much. When that seed's planted back, It's really common to see this slow and erratic emergence pattern, like you see in the top left corner here. And that's very common of glyphosate. It could be common too if you've got a lot of seed fusarium or other rot in your seed. But the other big thing you'll often see too is multiple stems coming out of the eye of a potato. The bottom right's pretty severe. The upper right is maybe more like what I would see, but oftentimes you'll get multiple stems coming, no dominant stem, so it takes them a longer time to emerge. Nobody knows, which one's in charge. And then if you have really high rates on the tubers, sometimes you'll see actually they'll almost like cauliflower formations on the eyes of the tubers. You can see enlarged stems. You can see maybe less roots or more roots. It does vary a bit. Those aren't great symptoms, but the big one I look for is either multiple sprouts out of an eye or no eyes with hardly any potatoes growing. But there's a lot of symptoms going on, but we try to narrow it down before we do like some kind of test. So here's a good view of a field that had a lot of glyphosate in the seed. And as you can see, some plants in the front didn't seem to have much, and other plants had a lot more as they were much slower to emerge. And then this is just a little bit of research we did a while back. This is just comparing plants in the field that were normal without glyphosate and those with glyphosate. The whole point is when you do have glyphosate, you're going to lose yield, you're going to lose size, you're going to lose in general. You do have, the healthier plant's going to be more competitive, so it's not probably going to be like this over the whole field. But when you have a strong plant next to a weak plant, that strong plant's going to look a lot better because it's going to compete a lot more with that weak plant. So we'll get into seed contamination a little more. Here's just a picture of two different seed lots that were planted same date in North Dakota. And as you can see here, certainly the one on the left has issues. The one on the right looked pretty good. Oops. So when you do run into some kind of problem, say with your seed or injury in the field or any of these herbicide things, okay, so what do you do? And I often get this question asked a lot of growers and people want to know what to do, right? And so we came up with this extension article here. You can look at, put a quick link on here, z.umn.edu/injury if you want to look it up. But kind of the summary of it is it's important to document that injury as soon as you see it, document the patterns, document where it's at in the field, take pictures of it, fly a drone over it, do that kind of work because like I said, oftentimes those symptoms might appear, they might be strong for 2, maybe 3 weeks, and then oftentimes they slowly go away and you might forget about it because you don't see it in the leaves anymore. But then you dig those tubers and you realize, oh shoot, those tubers don't look very good. They may not be very sellable, right? So it's really important to document the injury as soon as you can. You can always pull tissue samples and you can always pull tuber samples and even just throw them in a freezer and hold them if you're not quite sure what to do right away. But you can always hold them for the time being, but don't wait because farming gets busy. Everyone's has a lot of things to do and you might forget about it and it might come and bite you later. So document it, take good samples. The other thing is when we're sampling, we're often sampling an area that has the appeared effect of the herbicide with an area that is not. And when we're doing sampling, the key there is actually I use like latex gloves you can buy. And I use a different pair because those residues, you're looking for parts per million or even parts per billion sometimes. Those residues will rub off on your fingers or gloves between samples. So it's important to have clean gloves every time between samples. And also just like a clean bag, you can put them in. Just a little paper bag works great. If you think this might be a really big problem for you and cause significant financial losses, or there might be litigation involved, it's really important to have like a chain of custody of that sample from the time it's pulled in the field to when it gets to the laboratory. A lot of laboratories will have a chain of custody form that they can give you. And then we always just encourage growers to clean the sample. If it's a tuber, wash the soil off gently because you don't want to get a false positive. You don't want to get something that's in the soil but not in the tuber, and then get it to a laboratory. But those are kind of the main steps if you have some type of herbicide injury in the field that you suspect that you want to get tested for. It's not the funnest thing to have to do, but you need to figure this out because significant financial losses can certainly happen. So what do you do to mitigate some of these herbicide issues? Well, there's a number of things you can do. Like I said, know the field history. If you're renting land or swapping land, make sure you understand what's been in there. Use good, high quality seed because that's critical for a good crop. You're going to put the same money into bad seed as you're going to put into good seed, maybe more money into bad seed. So you might as well start with good seed. use good spraying techniques, like we talked about a little bit. Make sure you're cleaning up properly. Make sure those that are spraying are educated well. If you're a seed grower, I highly recommend getting a separate sprayer. Once you have one herbicide problem, you can easily pay for multiple sprayers typically. So it's a good insurance policy. And then if you're out scouting fields or looking at things and something looks suspicious, make sure you document it and sample it. So anyways, thanks for the time today. I hope you may have learned something, and if not, that's okay too. Put it in the back of your mind, and maybe someday it might be useful. So I'm going to stop there and be happy to take any questions that people might have.
Perfect. Thank you very much for that, Andy. We do have a couple of minutes left for some questions, and there is one in here from one of our attendees. Have you done any trials comparing yield with regenerative ag where a nitrogen fixing crop like peas are grown with potatoes and compared it to a potato field kept clean?
Oh, great. So we're going to jump right out of herbicides right into nutrition and fertility. Actually, no, I have not done that. It is a good question. And the thing is, I think, yeah, it's a really good question. It's a really good idea. I mean, because I think those are things we have to be thinking about in today's day and age, just with all the pressures we have from, from those that are buying our potatoes and the consumers, right? I mean, we have to be really good about what we're doing and how we're producing it and reducing the amount of products we're using. But no, I haven't studied that. Probably more of our, I mean, sidetrack this a little bit more, but more of my work has been, we have actually been looking more at utilizing manures. We have a lot of turkeys in Minnesota, so we've been on turkey manure and adding that in to reduce our synthetic fertilizer use. And also we've been doing a lot of variety trialing work, trying to find varieties that have lower nitrogen use needs so that we can use less nitrogen. But yeah, and I've got some other projects that we're working up, but yeah, we're trying to find ways to certainly get away from as much synthetic fertilizer production as we can. It's not easy. Because at the end of the day, a grower has to make money. You have to be sustainable, and part of sustainability is being economically viable, as your farm has to be.
Perfect. Sorry, a new question just popped into and we do have some time here, so one more question for you.
Sure.
Do you see problems related to calcium deficiency?
Okay, yeah, good question. I don't typically run into a lot of calcium deficiency problems in our area. I would say the main reason is we tend to have fairly good calcium in our soils in this area. And where we don't, I do see a lot of gypsum sometimes being utilized to help increase that calcium and sulfur. Is there some going on? I'm sure there's some somewhere. I mean, the area I work in, we've got pHs from 4.9 up to 9, but most of our pHs tend to be 6 or higher, and calcium tends to be fairly well available. So we've been working on some calcium nitrate studies. So we've been doing some work in that area, but not extensive work, I guess is what I would say. It's not a huge problem. So that's what I would say. So
perfect. Well, we really appreciate your time today, Andy. Thanks a lot.
yeah, my pleasure. Thank you, guys.